Hey kids, today we're talking about substitution to solve systems of equations. So I'll start out with this system of equation, y equals 2x plus 1 and 3x plus y equals -9. And I want to solve for x and y. So last time we learned how to solve by graphing, and where the lines intersect gives us the answer. If the two lines were on top of each other, meaning they were pretty much the same line, then we knew it was infinitely many solutions. And if they were inconsistent or parallel, we knew that there was no solution. So we're looking for those same outcomes today, but instead of graphing and getting that visual representation, we're going to start using some different processes. And the first one is substitution, which means substitution works best if I have something like this set of equations where I have one variable by itself equal to the rest of the equation, because very easily I can just plug that in here. So I can say that's 3x plus whatever this is, 2x plus 1, equal to -9. And then I start combining like terms. So I say this is 5x plus 1 equal to -9. If I subtract 1 on both sides, I get 5x equals -10. I divide both sides by 5, and I get x equal -2. And that's great. We solved for x, but we're not quite done. Remember when we graphed and we got those intersecting lines, we wanted a point. Well, every point has an x-coordinate and a y-coordinate. So I'm going to take this x and I'm going to plug it back into my first equation, or whichever. It doesn't really matter which equation you plug it into, as long as you plug it into 1. This one seems to be a little easier, so I'll plug it in there. So I have 2 times -2 plus 1. That's -4 plus 1, which would give me -3. So my point that I'm looking for here is -2, -3. Okay? Let's try another one together. We'll say y equals 4x minus 6, and 5x plus 3y equals -1. Okay? So again, I'm going to take that first equation and plug it in for y here. So that'll look like 5x plus 3 times the quantity, 4x minus 6, equal to -1. Notice I plopped this thing in right where y was, and now I need to distribute that 3 to both terms. So I have 5x plus 12x minus 18 equals -1. If I combine my x's, I get 17x minus 18 equal to -1. I move 18 to the other side. I divide both sides by 17, and I get x equal 1. Now remember, I'm not done with that. I need to plug it back in to my top equation. So if I say 4 times 1 minus 6, 4 times 1 is 4, minus 6 would give me a -2. So my point that I'm looking for is 1, -2. And that would be my answer. Try this next one on your own. We will start with x plus 2y equals 6, and 3x minus 4y equals 28. Notice I didn't give either one of them to you in a way where it's one variable equals the rest. So you might have to manipulate this first equation by moving the 2y to the other side, so that you start with x equals -2y equal to 6. That should help you get started if you haven't started already, and find out what x and y equal. So our final answer should be 8, -1. Okay? Make sure your work checks out like mine. And I know that this is a lot of work to be showing. I understand that. But notice I am showing all of my work. That way I can get partial credit on quizzes, tests, whatever. Okay? Let's try another one. We'll start a little easier. We'll start with y equals 2x plus 4 and -6x plus 3y equals -12. And we'll see what we get from here. So if you notice, when we get to this step, we have -6x plus 6x plus 12 equals -12. But if I combine like terms, the -6x and the plus 6x, that gives me 0x. And all I have left is that plus 12 equal to -12. Does plus 12 equal -12? No, so I should get no solution. Okay, if this is not true, it's no solution. What happens if it would be true? Good, you would get infinitely many solutions, or IMS. So let's try one more substitution type problem. Okay, again, I did not give it to you in a way that makes it easy to substitute one thing in for the other. So just for grins, I'm going to change my first equation, and you can solve for x or for y. I'll solve for x. So I'll start with 4x equal to 3y plus 1 by moving that 3y to the other side. And then I still don't have x by itself, so I want to, and that should be an x, I want to divide both sides, or every piece rather, by 4. Okay? So I'd get x equals 3/4 y plus 1/4. And then I'm going to start plugging that in for that x. Okay? So try plugging it in and solving for what y equals. When you start plugging it in, I will have 6y minus 8 times 3/4 y plus 1/4 equal to -2. I start simplifying and I get 6y minus 8 times 3/4. If I put that over 1, those cancel. That gives me 1 and a 2. 2 times 3 is 6y. And then I need to do 1/4. That becomes a 1. That still is a 2. But it's a -8, which is why it's going to be a -2 equals -2. So when I combine like terms, 6y minus 6y, again, that cancels out and I get that 0. And I'm left with -2 equals -2, which would give me infinitely many solutions. Okay? And we will work more on these in class, solving by substitution. Thanks for watching.